Yeah. No. So this is a talk on Docker, a worth whale tool to learn. There it is. We're done now. Yeah, that's it. I promise no more puns that are planned. If I come up with one on the fly, that's kind of on me. But this is also on me, but past me. We don't talk about past me. So yeah, I am Ciaran Broderick, ExOffico, and last year I was given the nickname Docker Boy because I love Docker. Hence why I'm doing this talk. Roadmap, just, I don't know why I do this, but sure, look, I'm going to go through it, Docker and containers. We're going to get started with Docker, because apparently those are two different things. We're going to see some cool Docker stuff. And then there's the reason you're all really here. I'm going to spill some company secrets. Yeah. My boss totally didn't give me the okay on all of these, so that's a joke he did. He knows what I'm talking about. Now I have to make sure I don't fuck up my direction. So what is Docker? It's written in Go. That's why there's a Go for here. Don't tell Noah. Well, he knows, but it's fine. Containers. That's it. Talk's over. See you all next week. No, that's it in a word. But then obviously you have to kind of go, what are containers? What's a container, sorry. And according to Docker's website, it is a standardized unit of software. Because open source is really vague about loads of stuff. So it's kind of like the words. A lot of people liken them to VMs, but like stripped out VMs, and I'm like, yeah, that works for a bit, but also they're not VMs. Just get that clear. I had a couple of slides in my last version of this talk emphasizing this point, but I'm just going to not have that argument again. Here's a virtual machine, okay? So you've got your server. This is the infrastructure of the server. You've got a hypervisor, which is a bit of software that allows you to have a virtual machine. And here's your virtual machine. And it's got an operating system, and it's got an app. And there's two more, and they have operating systems on them. And so does this. And it's like, this seems like a bit of a waste. That's a lot of storage you're using up for operating system when it's all the same, because they're all running the same operating system, because they don't have OS 1, OS 2, OS 3. So yeah, it's a lot of wasted space. So this is containers, right? So you've got your server, you've got your operating system. I don't know why they separated it out in this one. You got your operating system, because you can have a hypervisor and all that. That's fine. And then you have Docker installed on that, and you've got all these containers that are just apps. And that's really cool. Also, stop me at any time to ask questions, because I don't want to talk all night. I want breaks as well. So just shout at me. Maybe not shout at me, because I probably won't jump. But call me or something. I don't know. Just ask. Just ask. Okay. So word of warning. This is a really bad analogy. And I had that mentioned a couple of times in these slides, and Noah was like, you should probably just take out the bits where you're talking about how bad this is. Right, so we're installing an application on a VM, and it's kind of like setting up a tent. If you're installing it directly onto a VM, it's like manually setting up a tent. And then installing it with Docker is like a pop-up tent. Have you ever seen a pop-up tent? Does anyone not know what a pop-up tent is? Cool? Okay, we're all working with the same assumptions. For the purpose of this analogy, we're going to ignore taking down the tents after you. So imagine you're going to a music festival, because no one ever takes their tents home after those. So manual tent. So we got the ground. It's our nice clean VM that we have. And we need to install stuff on it. So you got to set up your tent poles, which are the requirements of your application, if you have any. If you're using Python, you probably will have a few. You got to get the tent fabric, which is your application itself, because that's the thing that you put up over your head to stop the rain. I don't know. I said it was really bad. Okay, just so putting tent pole. I don't know. Has anyone actually put up a tent before? Cool. So you know how hard it is to put up a tent? Yeah. For the purpose of this analogy, it's really hard to set up stuff on a VM, because it might take multiple people. And sometimes, if that's how your ops team is, it might actually take multiple people to set up your stuff. And if the poles break, you got to take them out. And if they're broken, it's really hard to get poles out of a tent. Don't know, has anyone tried to take broken poles out of a tent? Yeah, it's really hard. So I suppose that's the thing of like, if you need to upgrade your requirements, it's hard to do. I'll talk about how we did it in Kix and why Docker is just better later on. We've got a pop-up tent, which is our Docker stuff. So we've got our nice clean VM. We're just going to install it on a VM because that's how I do it. So we've got to install Docker on it, and there's really no analogy here. Like I can't. What do you put on? Maybe like a ground sheet or something, but most pop-up tents have those. So it's kind of lost for words for an analogy there. And you've got your Docker image, which is your tent in its bag, and then you just open it and throw it up in the air, and it's all set up fine, which is the container. And I have a really handy instructional video on how a pop-up tent works. It's really bad quality, but sure look, it'll do. So after you're done today, you'll be able to recreate this video, but get the tent up the right way around as well, hopefully. Yeah. There you go. That's Docker in a video. It's done all the work I need to do. So enough talk about tents. We're going to talk about Docker. Yeah, because that's what you're all really here for. You not want to hear about me talk about tents. You want to hear me talk about Docker. But we're going to mention tents one more time. Surprise, gotcha. So back in the analogy, I mentioned images and containers. Images are your built application or whatever ready to be run. Containers are just running images. Now we're done talking about tents. That's it. I promise. So if any of you actually want to follow along, I'll leave this slide up. Is anyone actually going to bother? There's no laptops out besides Alex and Colin. You want to follow along? Have you installed Docker already? Okay, cool. Linux get it really easy. You just run this. Trust me. Really, well, you might have to use sudo sh, but whatever. For Arc, it's in the community repo. Last year I didn't use Arc, so I didn't mention this. So that was a new bit. This side is just ripped from my last year's talk. And for Windows and Mac, you got to follow this, and I'm not going to because no one develops on Windows. It's just no one develops on Windows.
No one with a laptop uses Linux right now.
That's true, actually, yeah.
Well, you've already got Docker, so I don't need to deal with that. That's fine. Yeah, and also Mac have to be weird as well because it's not enough to just install Docker normally. Okay, so have you run this before, Colin?
I don't know. I might have.
Okay, so when you have it installed, go try and run Docker run hello world. And we're all going to wait for Colin to do the thing.
No, this is probably.
This is how the talk's going to take a while.
It's downloading.
Oh,
It's a hello.
did you get a message that looks like this?
And a lot more, yeah.
And a lot more, or we'll get onto a lot more. So you'll get a message that looks like this. And it says, hello from Docker. It says it's working, yada, yada, yada. You've all done hello world by this point. You know what it does. You know what it means. So a bit more on images. In the output of the last command, you might have seen something like this. Did you see something like this, Colin?
Did you learn?
Yes.
Hey, that's cool. I'm glad that the follow along part's going really well so far. What this means is, so you've got find image hello world data. So this is the name of an image, and this is a version, and Colin didn't have it installed, because why would it? So it's going to pull from library hello world. Because it's not on your computer, it's going to pull it from somewhere else. But then, where is this somewhere else? It would be really handy if there was a website where people upload Docker images for various widely used applications. Oh wait, there is. It's the Docker Hub. And that's where you got that.
Yes, that's a new image.
Yeah, they actually recently did it up, and I was very surprised. So, Docker Hub, there's nearly 2 million available images. That's really bright now. You've got stuff like Oracle Database, Oracle Java, MySQL, Oracle. Why is there so much Oracle? There's Couchbase, DB, you've got loads of different efficient images for different stuff. Like if you do programming languages, you've got Docker images for those. Python has one, Go has one. There's loads of different images. It's great. This is great. There's going to be an image I show you guys in a while that I use quite frequently, and I'll get onto that in a minute. Oh boy, okay. But the real thing we're going to talk about is building our own images, because I had something witty to say here and I can't remember what it was. Can you all hear me okay, by the way? I feel like I'm talking really quietly. Cool. I like the unison nodding that I got from that. That felt really nice. Thank you. So we're going to talk about building our own images, because that's really what you want to do when you're using Docker. You can use like pre-built application ones as well, but if you're working on an application, you're probably going to want to build a Docker image of it, and you should, because it makes your life a lot easier. I'm biased though, so be warned. So the Docker hub is great, but it doesn't have Docker images for my stuff, says someone. Yeah, it's such a disappointment, isn't it, Colin? But that's because you've got to build your own. I know it's so much work, and we're going to talk through doing this. Now, I don't know how this is going to work, because I do actually have a full example made up, but we don't have to go, like, we don't have to wait for Colin to do it if he doesn't want to. Do you feel,
I can do it.
would you like to be my assistant for the night? Cool. Okay, so, example, kernel panic. Nope, that's not it, that's spoilers. Just for reference, my Netsoc website, as some of you may know, is kernelpanic.netsoc.co. So that's going to be relevant, trust me. So I said, what's the best way to make an example for this? What if I make my Netsoc website standalone? I have a nice website at kernelpanic.netsoc.co. It actually is. If you say it's not, that's your opinion, and you're allowed to have one. It's very purple, I know. MJ. I want to make a standalone version using Flask, which is a Python thing. Not going to talk about that. We're not doing a tech talk on that this year. We did one last year. Hassan did one last year. Is it up? It's not up on YouTube. Cool. It's a cool little thing, but we're not going to look at it because it's outside the scope of the talk. I want to use Docker to deploy it, because if I didn't, I wouldn't be talking about it here. And I guarantee no one has made one for me because it's a new project. I literally just made it this week when I should have been doing work. Okay. And if you want to follow along, if you go to my slides, you'll go to this slide. That's kernelpanic.netsoc.co/tech-talk/Docker. We're all going to wait on Colin, my lovely assistant, now again. Yeah. I should have told you in advance, to be honest.
Yeah.
That is, if you want to know, that's slide number 7. Now, you do have Git installed, yeah?
No.
Really should have prepped my assistant for this.
No, I'm not good. I had stuff.
Sorry to put you on the spot, friend.
Should I film it?
I forgot to. Yes, you should clone it. Yeah. Past me is obviously expecting current me to say other stuff than what's on the slides.
It's a GitHub repo. Just for people at home.
Oh yeah, I'll show you. I'll follow along on this computer despite it having. So this is my GitHub. There's a Docker file, Docker word. That's important. It's just code. That's really bright. I don't like. Oh look, this ugly ass color. They changed Docker to. Oh, really annoying. Go stole my nice color.
There's a kid where you can
Huh?
make pull requests.
I think they made a pull request to change it to that for some bizarre reason. So have you got a clone? Cool. There's that word again, Docker file. We saw that a second ago. And apparently, according to past me, we need one. This is a set of instructions for Docker to follow to build an image. Simple. And what we need to do is, we need to copy all the code onto the image, install the requirements, and then set the command that when you say run this image, that's what Docker will go, okay, you want me to run this line, or this command inside the image, that's fine. So, now there's scrolling to do, right? But I'll go through this line by line, it's okay. I know it looks scary, and also kind of the color scheme doesn't really work with my slides, but whatever. So the first line is from and Python 3.7. So basically, when you have a Docker image, usually, unless you're doing some like really low-level images, you would base your image on another one that exists already. So I'm saying, base my image on the version 3.7 of the Python image, because I'm using Python. Because, yeah. So basically, English. Basically, what this will do is it will grab the version 3.7. That's called a tag, by the way, the stuff after the colon. It'll grab version 3.7 of the Python image. If you don't have it installed locally, it'll pull it from the Docker Hub. And then it'll run every other command on top of that in this Docker magic, which involves layers, and it's really cool, but I also don't know how it fully works, so I'm not going to talk about it in case I make a mistake. Yeah. So that's fine. Then you have a working directory, which I set the whole kernel panic public HTML to try and mirror the directory structure of Leela. I know that there's home users kernel panic public HTML, but that's fine. It's close enough for my liking. And that basically just sets your home directory for everything else coming. Third, you've got copy, dot, dot, and that's not really confusing. It sometimes confuses me. So basically, when I say build, and when you say Docker build, and you pass a directory, that directory and everything inside it that you pass is known as the build context. And you're basically copying the build context to the image at the working directory. You can do more than 2 parameters here, and it will just assume all except the last are from the build, or the path from the build context, and the last one is the path of the image. But usually you probably just do dot dot. It's fine. If you do dot dot, it will probably work. There's no issue. It's going to be fine. If there is an issue, at me on Discord, and I'll help you. Next thing I want to do is I want to install my requirements. Because we're working from the Python image, we've got pip install. So we just pip install my requirements. Don't mind this. This is a cool new thing I found out about very recently, and that's how I'm managing stuff. This is basically pull my tech talks from the other repos that they're up on my account on. So that's fine. I'm not going to go into that because that's not stock SK. We want to expose port 5000. So basically we want to say, hey, Docker container, when you run, please have port 5000 open for me so that I can connect to the container on port 5000. And lastly, we set the entry point. And it's Python 3.7 at top line. And there's also, you can also say CMD. There's two different things. You can say CMD. I should have put an example. But basically, I had like really long slides on it last year. But what the difference is, you can say, and I'll come back to it in a minute. I have a good example. Yeah, just trust me, I'll come back to it. And if I don't come back to it, someone please shout at me and tell me to talk about command versus entry point, because I should have done that again this year, but I already feel like this talk is going to be a very long talk, and this talk is not making it very easy to tell how long I'm doing. Yeah. Because this one is moving, the hour and the minute hands are both moving at the same time. So who knows what time it is? Because I don't. Thanks, Homer. Appreciate you. I think that was the end of the Docker file. And this is the Docker file taken straight, nope. I hate touchscreens. This is the Docker file taken straight out of the repo. Colin can verify if you just show it, yeah. I'll trust that he sees what I'm hoping he sees. So step 2, once you've got your Docker file written, you want to build your image. I'm beating myself to the punch here because I basically said that word for word. So in the project directory, you can run the following command. Docker build. And then there's some other stuff. But this is, it's fairly self-explanatory. Hey, Docker, build my thing. The -t is a flag that says, I want to give it this name. So we have Python :3.7. This is kernel panic. And if you don't do colon something, it defaults to colon latest. And then the dot is your build context, which is the directory Colin is hopefully running this command from.
Yes.
Cool. Are we working?
Yeah, it's installing.
Class. Right. It does take a while, because I know I mentioned layers and I said I wasn't going to talk about it, but basically all these run in different layers, and then an image is just a cake of layers put together.
It's done.
Is it done? Cool, I don't have to stall anymore. Running the image, kind of the other important part, because why would we be talking about Docker if we're not going to use it to do stuff? I English good. After building it, we can verify it is there by doing Docker images, which should show you at the top. It's latest for, you've got a lot of images of that, yeah. It should be right at the top, give you one with the tag kernel panic. Yes. Cool. It's all going really smoothly, and I'm kind of getting worried now. To then run the image, we need to do the following. This is going to be a long one. right? So it's Docker run minus P stuff minus D and kernel panic. So you can ignore minus P minus D and just say Docker run kernel panic, and that runs your Docker image. But then if we don't ignore this, because this stuff is also important, minus D says run in the background. Otherwise, your terminal will get attached to the terminal of the Docker container, and you'd see all the output from the container. And then if you control C, you'll stop it. So some people, if you want to do it that way, that's perfectly fine. And then minus P is port forwarding. So this says take the hosts, so Colin's computer, port 5000 on Colin's computer, and link that to port 5000 of the container. So you know how earlier we exposed port 5000? And I promise that's not an arbitrary number, that's just the port the Flask uses. So instead of having to find the container IP, which is hard, and go to that port 5000, we can just link it so localhost port 5000 goes to the port 5000 of the image, of the containers. Whoa. Oh shit, yeah, come on, you're not. Sorry guys, look, this is really important, okay? Thank you. Oh my god, it is really nice.
Oh, lovely.
Okay, bye Liam. Oh, this looks real good. Cool. Moving on.
Bye.
Bye, Cian. Cian, everybody. I forgot his surname. McGrath. There we go. Cian McGrath, everybody. So did you run it for me?
I did.
Cool. Now to verify that it runs, can you go to localhost port 5000 for me?
No, the computer's broken, but I can go to 127. Yeah, I can.
Pedantic AF. Do you see the website on Colin's screen? Is it working?
Yeah.
Holy shit, it is actually working. I do actually call anyone out. Basically saying, "Not my check it works. If it doesn't work, it's your fault, but it worked." So, and you're the only one testing it, so at least I'm not calling out a whole room of people. Also, you can use the following commands to list all running containers. Docker PS shows all running ones. And the next one's going to show a lot of output on your one.
Yeah.
Docker PS minus A shows all of them dead or alive. So if you want to find out, hey, my container's not running, why not? And then you run PS minus A and it says, oh, because it gave exit code 255. What the fuck is exit code 255? I don't know. Don't work with LDAP, anybody, please. It's really annoying. Am I going too fast, by the way? I feel like I am. Please shout at me. With valid questions, not just shout at me for no reason. Thanks. Some other cool stuff. Before I spill some company secrets, which I know you're all really here for me telling you about where I work and spilling trade secrets, I do have to show you some other cool stuff. Okay, so Colin, I'm going to need your help again. This is the flag -V. And it's pretty cool. Especially if you're doing web development, which is what this is. This jacket's so nice. If you run this instead from the project directory, so you'll notice I've added there. Thanks, Sarah. So if you run this command, -v says, so -p says use host port to container port, -v says mount directory on host to directory on container. And if you remember back, does it not work? Oh yeah, you're on Windows. This is built for Linux people. So sorry, Colin, you're gonna I'll come back to you.
Thanks.
This is like bash substitution, so this gets the full path where you are at the moment. And if you remember back to my Docker file, we said this is where the work directory is. So we're basically saying mount my copy of the files to the same place on the container. And you're like, and you might be like, but why would you do that? That sounds stupid. But no, it's really clever. Because if you edit files, the container updates in real time. Only HTML files. Obviously, if you edit the Flask file, you have to restart everything. But you could make changes to my website and update it in real time. So you can make me look like a real stupid person and get rid of my tech talks or something and make me look like I do no tech talks and then put it on Discord and be like,
your website's broken.
Did you actually break it? Or?
I broke it, but I don't know.
See, you can also just break my website if you want. That also works. It's probably templating or something.
Yeah. You actually have to delete it.
Oh, yeah. Yeah, you can delete everything and then... So whatever, do whatever you want, basically.
That's weird.
That's handy if you already have your application Dockerized, which I do, and want to do development work, which I don't know if I'd call that development work, but you can do stuff to it as it's running, and that's pretty cool. Especially for web development, as I mentioned earlier. So I develop a lot of websites because I have no time on my hands, or too much free time on my hands. I don't know, whichever one you want to prefer to say that I have. Working on a new web project, you don't want to install a patch on your machine to test, or Nginx if you're that way inclined, I'm not going to judge. You can just run this. This is a command literally copied out of my bash history, because I do it so much. You're basically managing your web project to, just trust me on this one, Apache is weird, where Apache is looking for folders, for files, minus P8080. If you don't do minus 8080 or current 8080, if you do 80 to 80, you'll have to run it with sudo because you can't manage stuff to ports under 1000 by sudo or something. And then HTTP. And again, if you don't have it, you'll pull it. And if you do have it, like I do, again, I use this way too often, then it'll just run. Pretty sure I gave out to Evan and Noah on our Discord group chat for not using it, for using file, file URL when you're doing web development. If you've ever had Derek Bridge for web development, he would kill you for using file URLs. And then they were testing the file URLs, and I was like, lads, just run this. So that's in our Discord group chat somewhere. Probably. Unless we deleted it, I don't know. I'm spilling all kinds of secrets here. No one's safe. This one's for Oshin. Docker Compose. He asked me to put it in, and I said I'd put it in. So what if you have an application with a lot of required external services, like a database or a load balancer or etc., whatever that is? I'm really bad at humor, apparently. You could set them all up yourself manually, or you could use Compose. It's installed separately. So if that puts you off it, then sure. But basically, I didn't have enough time to come up with a really clever use case for this. But let's say I want to use Redis with kernel panic for some reason, like maybe caching, I don't know. There's nothing from the database. So look, just pretend I have a reason to use Redis, which is a cache, with kernel panic. I could have the following compose file. This is all magic. I don't understand any of it. I use Ansible, but Docker Compose. You've got an image, you've got your web service, and your image is kernel panic, which we called it earlier, and you say you forward this port, and you've also got Redis, and the image is Redis Alpine. And Alpine is a special Docker image. It's really small. So it's what you build your production stuff with, because you want to keep your images really small. Because, as I mentioned like ages ago, VMs take up loads of space, and you don't want your Docker containers taking up loads of space, because then you kind of just defeat one of the purposes of moving to Docker, or something like that. And then you can bring them both up just by running Docker Compose up -d, and it'll run them both for you, and it's pretty cool, I'll admit. And that's basically all I have to say about Docker Compose. You're welcome, Oshin. Another cool thing, Kubernetes. This is a word you're probably going to hear a lot. Kubernetes, I just took this from their website. It's an open source system for automating deployment, scaling, and management of containerized applications. And that's literally all I'm going to talk about, because it's outside the scope of this talk. And also, I don't know it very well. So next year, if we do a Kubernetes talk, I'll learn it, or I'll come to it and have someone else who knows it better explain it to me. And people who wrote the last year's talk will remember this, but I have to show it off again, because it's really cool. This is a tool someone made called Docker Doom. You know Doom, the game? This is a really cool tool someone made to makes 2 Docker images. And did it stop? Okay, no. And he does this really cool thing. Basically, just give him a second. So he brings up an image, he runs his Docker Doom thing, and he VNCs into this image. And then suddenly, he's playing Doom. But it gets way cooler again. I know it's really bad quality. He also turned down God mode. So because he's a cheater. But whatever. He also turned on NoClip because he's a real cheater. But basically, now it's really blurry and it's really bad quality, but you can see two enemies and you can see they've got numbers and names next to them. Basically, he made a tool that pulls all your Docker containers and turns them into enemies inside of Doom. And if you want to kill your Docker containers, you have to go into Doom and literally kill your Docker containers. Why? I don't know. Do I love it? Yes. Yeah, that's literally, he comes back out and he runs Docker PS again, and they're gone. They're here, and now they're gone. I don't know how, like, whoa. Someone stole my picture. There's also some, this is really cool, recommend looking at that, machine learning for Mario, well worth looking at. Again, not going to talk about it because it's not Docker related, but yeah, Mario machine learning. Nice. Nope, that's not what I wanted to do. What have I got now? Okay. The moment you've all been waiting for. The moment that could get me fired, except not really, because I've showed my boss this part of the slides already. Actually, I haven't, but I'm showing it to him right now in the future. Okay. So I'm not like going to be like Colin from last week and what's the word? Recruit people. I'm just going to tell you about how we do shit. This is the diagram on our website, and this is all the stuff that we have. Evan knows this very well, don't you, Evan?
Yeah.
Thanks for the confidence, Evan. Right. So we have a load of APIs, REST APIs, and we've got a load of front ends. Okay. And when I started last May, June, around that time, June I think, all of this was written in Python 2 and Django. And now it's moving to Python 3 and Django. But the issue is, see all these? They're all like big applications, big REST APIs. They all sit on a single server. Anyone ever heard the term monolith before? With regard to software, not like big rocks, but same basic principle. So this is, Jerry believed, I'm not going to call him out on anything, but like we use the term microservices. That's probably a word that people have also heard. But this is not microservices. This is monolithic because it's all in the one place. And I even brought up our specs. And I don't know if I'm allowed to share that with you, but too late. It's already been shared. So we have all our applications on one server. The front ends are the same, but for the purpose of this, I'm going to talk about the back ends because it's the one I've had experience in doing already, because I've already upgraded one of these to Python 3 and Docker and Kubernetes through a helper front-end thing that I don't know how it works. It's magic, and that's the way I'm going to leave it. So this is what we've gotten. This is a very stripped-out diagram of how we've gotten our membership application to look like. This is just 2 physical servers. There's 4 of these. They've each got 2 workers on them. One of them is yellow. That means it is a control plane, which means it can be in charge of the whole cluster. One of them is green, which means it's just the basic boy. And we've got some cache and spacing workers, and that's duplicated across servers as well. And they're all the black box outline thingies are 2.8 gigahertz quad core, 4 gigabytes RAM. And you're like, you've taken away 3/4 of the RAM. Why would you do this? And I would explain, because it's better. And I've beaten myself to the punch. Okay, why is the second one better? Well, I've got loads of reasons apparently, because past me is great at writing stuff. Resiliency. If one server goes down, we don't lose the API, the membership API. Because like, this goes down, we lose everything. That's not really good when your business is APIs. So, yeah. This is great, because I don't think I've actually ever fully explained my methodology to Jerry, so if he watches this back, he's going to finally understand why I've been spending months doing this. I hope. Load balancing. As you saw, the black outline box thingies, they're different physical servers. We now have multiple servers able to handle requests instead of one. Doesn't sound like a great improvement, kind of sounds like we're paying more money on electricity because now we're running more stuff, but it'll be worth it, trust me, I hope. And we got fragmentation. If all the servers go down, we lose a single application, not all of them. Oh yeah, okay. I forgot what I was writing here. So basically, if all the membership servers go down, we just lose membership. We don't lose everything. Except I have to start here. If we lose membership, we do actually lose everything, because everything else relies on membership. But that's the general case. Did you finally understand what I spent months on, Evan? Did you finally get it?
Yes.
It's great having someone else I work with in the audience. I get to pick on them. Also, there's a speed increase. And again, this comes back to how did taking away 3/4 of the RAM make it go faster? But that's kind of because I might have talked about this later. I needed to test if this was an improvement. This is just me bragging, actually. That's what this is. So wanted to do list 100 users from Python 2 Live versus Python 3 Stage 1,000,000 times. I ran this overnight. I'm not that much of a time waster. Calculate average time locally, so that's full request response time. And I made it 57 times faster. No, don't actually. I'm not this show offy. I just wanted to talk about it because it's a case study, and you got to talk about everything in a case study. Okay, so this is the thing I was originally thought this slide was going to be. It's how we did it. It's mostly due to the architecture change of moving from one big server to loads of little servers. It's because, I send 4 requests in a second instead of one server having to go through all 4. I've got 4 servers handling one each, which is inherent because then it takes the slowest one instead of all 4 of them. Also, original API running as a monolith on a single server, new API running as clusters of smaller servers. I'm not going to hand it all over to Docker because the code was kind of bad as well, as I keep saying. But it's mostly this. Promise, it's mostly related to this talk, so I'm going to mention it. I also talk about deployment because Docker makes deployment a lot easier. Okay, so we've got GitLab inside the work, and that has continuous integration and delivery. So we automate deployment. We use a library called Fabric, and that basically what that did was it went onto the server, the single server, remember, ran into the folder and just got the latest version from the repo. But the deployment scripts never actually contain jobs to update requirements. So sometimes your stuff would just break, and we'd be like, why did this break? And then it turned out it was missing the latest version of a library that we needed, and that got really annoying. And also, Fabric is like a Python script, and half the places it was called, jobs were like deploy_live, and then half the places they were live_deploy, and it was like, I don't know, just loads of things. New deployment system, it's still automated, build Docker, Docker goes onto the clusters, and this is the cool bit, right? Now, I don't think it actually ever brought down the server. Oh, it did, yeah. Bad deployments in the old one brought down servers. Bad deployments in the new one don't bring down anything, because basically Kubernetes will go, here's the new one, try and get that up and running, and if it doesn't get the English, if it doesn't get it up and running, it won't shut down the old ones. So you're always going to have stuff online, and then we'll get an email being like, hey, your deployment failed, and then we can go find out why, and it's pretty cool, in my opinion. I don't know if it's cool to the rest of you, I just want to talk about work. Because Docker's great, everybody, okay? Look, just trust me on it. What's this one? Oh yeah, this is where I call out Netsoc. This is great. So I've Dockerized my application. We're done with the case study now. So I've Dockerized my application. How and where do I deploy it? I don't really call it Netsoc. I call it one person in Netsoc. How and where do I deploy it? Keep your eye on this project for Netsoc's own containers as a service platform. This project has to be renamed, unfortunately, but it's called Derek. Noah showed me a link today in the Discord that said we have to rename it because someone else had a Docker project named Derek. So, and their one is done, so we can't use this one. We can't use the name for this one, so that's a problem we have to face at the moment, is renaming that. Other cloud providers support containers, but I don't think there's, you've got AWS free trials. I don't think there's a free trial for containers. I could be very wrong. kind of looks like he's about to prove me wrong, which would be great. No, if I'm wrong, I'm wrong. Like, Cloud Kicks will also be getting containers as a service at some point. What was that? Oh, keep going. Okay, I promise we'll get around to containers, which means Netsoc will also get that as well. Oh, huh. Is it worth us working on our own one if we're going to get? Well, it's going to be years, so yeah. And if you're really anxious to deploy something, ask the lovely Netsoc sysadmins, aka Noah, where Derek is. Except not Derek anymore, because we have to change the name. Don't harass Colm or anyone else, just Noah.
Yeah.
And as far as I'm aware, I think I'm done. Oh no! So I did a thing like a couple of months ago, and they taught me how to present properly. And you're meant to tell them what I'm going to tell you, what I'm going to tell you, and then tell you what I told you. And I was like, maybe I should put in a conclusion slide. So I'm going to put in a conclusion slide. We talked about containers versus VMs and how they're not the same, even though I didn't go into my rant from last year's talk. Let's see if I can remember any bits of the rant. They're just not, okay? They're just different. Architecturally different. Even though, oh, hang on, Noah wanted me to say something. Containers have their own file system, so they're kind of similar, but it's just they use the host OS and not have their own one. And that's all I can remember. Tense. Installation of Docker, the Docker Hub, how to build your image. Ooh. Time is meaningless. How to build your image, Docker Compose, Kubernetes kinda, company secrets that my boss let me share, and another cool Netsoc project is coming soon, maybe. Yeah. And I don't know, I think I'm done. I am done. So please, God, ask me questions, because I missed out on so much. Please hit me with your hardest questions. And I will talk about command versus.
Yeah, I was just going to say.
Thank you. Was that what you were going to say as well?
Yeah.
Cool. Right. Thank you. And I'm so glad someone remembered to ask me. Let's yeet all the way back a good bit. Where am I going here? I want to go to where I run stuff. Okay. Okay. Entry point versus command. So, they're interchangeable, but they also work in tandem. Entry point is basically the entry point. I know that's kind of using the word to define itself, but I'll get on to that in a second. And then the command is, so basically when you run a Docker image, it runs the entry point and then adds the command on after it. So you could do, one example would be entry point Python 3 app.py, and then command is debug, and it runs with debug mode on, okay, or something. But also, if you put stuff after the name of the image when you're running it, it will take everything you put here and pass that in as a command instead. So if I have entry point Python 3.7 app.py, and I don't want debug to be the default mode, I could say docker run permapanic debug, and it would run it in debug instead. What are you laughing at? Is it related, or is it like, okay, as long as it's unrelated, as long as you're not laughing at me, that's fine. Hang on, we'll give you a second to chill. Any other question? I know that was a terrible explanation, but like that's basically the best way to explain it, is kind of just be like, they work the same but differently. You can change command and you can't change entry point as easily, if that makes sense. So you could do, if my command was Python 3.7 app.py, and I just wanted to run a shell, running shells inside containers, that's a good one to talk about. I'm just going to do some HTML editing here, because I forgot to mention this. Yeet, don't look, I'm hacking my talk, boys. You two having fun back there? I hear a lot of people like angrily talking at each other. Kernel panic dash. And then save. Cool. Imagine I can change my tech talk at will. Oh, that's still up there. Hang on. It's not going to look as big if you don't. Right. So They're two separate flags, but together basically in interactive mode. If I command was Python 3.7 app.py, but I just want to run a shell inside the image, run this, and it goes, you just have a shell. And I do this more often than I'd like to admit, to like debug stuff and figure out what's going wrong. And I just heard Colin say it's great, so it is great. But yeah, like the best thing I could say is just to get the difference in your head, just mess around with both of them and just. So you could literally change entry point to command and nothing will change. It's just what you do after the fact is what will actually make a difference. If you put anything after kernel panic there, it'll do cool stuff. Is that any other questions? Please, God, tell me there's questions. Oshin.
When you use microservices, what do you use to communicate between them?
So we use a thing called Rancher. Have you ever heard of it?
Yeah.
Yeah, it's basically, it takes all the work of Kubernetes out of it, and it does magic stuff, and I don't question it.
Okay.
I'm like, what do you mean? How like talk between them?
Like message brokering, that sort of stuff.
Oh, they're completely standalone. Like they're just REST APIs and they talk to a database. There's no like there's yeah just other applications will just use the REST API membership then.
Okay.
So that's just how the system was designed. That's how Jerry wants to keep the system designed. So I'm not going to change that. Although we might be adding GraphQL at a later date, so that's pretty cool. Maybe, hopefully. That's also something cool. If you want to learn a cool technology, look at GraphQL. It's pretty cool. Although it is made by Facebook, so I mean, if that stops you from learning it, that's fine too. Any other questions? Please ask.
How secure is Docker?
Didn't they recently find a very bad run-C vulnerability?
Yes.
Was it the first major CVE found in Docker?
Yes.
Yeah.
Like last week.
Thank you, Colin. I'm so glad I saw that. Basically, they found a big security exploit in the thing. Oh, look at, hang on, what's this cute thing? Oh, it's Valentine's Day. Sorry, this wasn't romantic. What was I looking up? Docker. Type for me, please.
That's good.
I think the keyboard is clearly working.
Try it on.
Oh, there we go. Docker CVE runs. This one? Yes. Okay, no, that's not the actual attack. Where's the actual just CVE website, please?
You can just go to Kubernetes.
Kubernetes
Oh,
blog.
this
This one? Basically, last week they found a big container escape vulnerability in runC. Do you know what runC is, Colin? What is it?
This thing that runs games.
That's pretty well named, actually.
Yeah.
Oh, it's right there as well. I know I asked that as a legitimate question. I didn't know what it meant. What is the vulnerability? It basically, you can exploit a bug in runC to gain root privileges on the host running the container, which is kind of bad for CAS platforms, because you could take over their server and do all kinds of shit. That's kind of fun for black hat people and not really great for everybody else. So fair use to the people who found it, though. That's pretty cool. But other than that, I'm pretty sure it's secure enough. I mean, it's been going for like it's in its 5th year now, isn't it? Or 6th. It had its 5th birthday there last year or something.
Oh, it's older.
It could be older. I'm not knowledgeable of like the semantics of things at all.
Oh, 5 years ago.
Oh, I got it right. Cool. So yeah, it's if you're running a big server with Docker on it, it could be scary if people get shell access to the Docker containers. But all of ours are behind firewalls, so that's okay.
Don't use it as security. Don't use it as security.
Don't use it as security. That's a very good
That's
point.
the virtual machine.
That's what virtual machines are for. Virtual machines are more secure. Cool. So if you want to be that guy, we put all of our Docker containers on virtual machines on physical servers. I don't know if that makes it more secure or less secure. I don't know what the semantics are, but it's just a lot easier to deploy virtual machines when you're building a cloud. So makes sense for us. Any other questions? Work kicks related or not, or Docker related, or just in general related? Why does no one ask me how I am anymore?
Aww.
No, seriously. If that's it,
What's
then
your favorite thing
about
Docker?
See, I used to be like super excited about Docker, but then, okay, hang on.
It doesn't work.
And then I used it for a while, and I'm like, yeah, this is pretty cool. But the initial excitement wore off. Coolest thing, my favorite thing about Docker, my favorite thing or the coolest thing? My favorite thing about Docker. It has to be this boy. It has to be this. Look at this. Look how happy he is.
What's the coolest thing?
The coolest thing about Docker.
Also the whale.
Probably the coolest thing that I found is, okay, this is going to be kind of a long-winded question, a long-winded answer, but the coolest thing about Docker is probably like stuff like Swarm and Kubernetes. Docker Swarm is like Docker's version of Kubernetes, but as far as I was aware, they stopped working on it in favor of Kubernetes. But then I see stuff still talking about them working on it, so I don't know what the story is there, but like how people do this magic that makes containers work. Someday I'll learn how it works. Well, not containers work, but like, you know, loads of containers on the same thing talking to each other. I'll learn how it works eventually. I just have a lot of books to read before that. I got a book today. It was Docker in Practice, I think. It's a big chunker of a book, so I'm going to read that soon. But yeah, that's probably the coolest thing. All this like system stuff is magic to me, and that's how it's going to stay forever. Anything else? You don't actually have to ask me how I am. I'm actually doing all right. Also, I did a really cool Dockerfile question slide thing. Okay, I think we're all good. I think we are. Yeah, thank you all very much for coming. Hope you had a lovely Valentine's Day spending it with me talking about Docker. I'm going to go home and get takeaway. There's my links, Tech Talks, the Git repo, the example, the column. Can we get a round of applause for my lovely assistant? And yeah, you're never gonna. I'm not gonna do any more Tech Talks this year. 3 is my max. 3 is that's it. I'm done. Unless I get asked back, then of course. But yeah, thank you all so much for coming. Hopefully I gave a good talk. But yeah.